All right, let's get going. So I have an old exam question for you here, and I just want to ask a question about this function over here. What type of function is that? I drop down the camera. I will do. Yeah, it's a parabola. Awesome. And it has a quadratic equation. Now, first question that you need to do today is find me the coordinates of A and B. There are two functions in this question. The one is a parabola, which we have just mentioned. The other one is a straight line. And I want you to try and find me the coordinates of A and B, which are points on the graph in this drawing. So over to you guys, see if you can find those. And you can pop them in the chat. So we're trying to find what the coordinates are of A. And we're also trying to find what the coordinates are of B. And if you notice anything special about what A and B are, pop it in the chat so we all can know. They are the y-intercepts, exactly. So A is the y-intercept of F, and B is the y-intercept of G. And so, because in order to find what the y-intercept is, we make x equal to 0. And for F, if we do that, we're going to get a 3. So we get 0, 3 for A. And for B, if we make x0, we'll get 0, -1. Yeah, there we go. That wasn't so bad. All right, find me the length of AB for the next question. Find me the length of AB for the next question. What's that going to be? So the length of AB is really just the distance between A and B. And you can see it's 3 to get there and another 1 to get down there. So it's going to be 4 units, which I see in Paul, Tova, Marang, Fila have all recognized. Okay, cool. So 3 marks in the bag. Let's go on to 3.1.3. Godfrey said y top minus y bottom. So you're absolutely correct. You can go 3 minus -1, and that will also give you 4. Okay, so next bit, we want to find the coordinates of C and D. What is special about C and D before you go off on your mission to find them? What stands out to you about C and D? They are the x-intercepts. Yes. Flamelo and Paul, that is correct. So we know to find the x-intercept, if we think back to our lessons on graphing, to find the x-intercepts, we make y0. So you are now going to use that knowledge to help me find the coordinates for C and D. Over to you guys. I guess I'm going to have to go x squared minus 4x plus 3 is equal to 0. And then I have to solve this, and I have a choice. I can either use the formula or factorize. So now the question is, a lot of students are saying that x is 3 and x is 1 if we solve that quadratic, but which one goes with which? And if we look at the drawing, the c is further to the left, so it must be the 1, and then its y coordinate is 0. And then the d, which is the second one, it should be 3, 0. Okay. So far, again, let me know in the chat if things are unsure, but things are looking okay so far. Now, 3.1.4, I want you, I'm changing the question. I want you to find me the intersection points between F and G. So this question is now going to be find the intersection points between F and G. Now, think back to when we talk about the intersection points, they're where the two graphs collide. And so it looks to me like I need to find these two values. I'm going to basically say it over to you, but if you want to say in the chat what you think you should do for those who have been away, or maybe have missed a couple of lessons, how would we find the intersection point between F and G? Some very helpful tips from Kat and Impor and Fila and Romelo. So they're saying equate the two functions. So oh yes, Samsonti, let's go to you.
So you're going to equate the equations.
Perfect. So I'm going to actually do that now, and then I'm going to ask you, what would you do after you equate the two? So I've done that. What would your next step be?
Then you're going to solve for x.
Okay, perfect. So we need to solve this equation, and that will help us find our intersection points. Thanks, Samsonti. Let's see if we can do that. It feels like I would probably want to get this into standard form. And if I did that, that's the standard form that I get. Now I've got to decide, do I solve this with the formula or by factorizing? It's not always obvious, but in this case, it happens to be a nice one. And so I'm getting x is 4 or x is 1. But remember, I want the intersection points or the coordinates. Now I'm happy that x is 1 because x is 1 is what I expected to get for this one. But I still need to find what the full coordinates of f are. And at the moment, I know that f is in line with 4, but I need to know what y value it is in line with. Okay, so I need to know what that is. And okay, visually you can kind of see it, but just to be sure, what I would do is I'd take that 4 and put it into either of these two equations. And so, for example, if I had the g of 4, the g of 4 would just be 4 minus 1, which is 3. And so the coordinates of the turning points are going to be 1, 0, and then f is going to be 4, 3 for the intersection points. Thumbs up if that's feeling okay. Thumbs down if you're feeling a bit confused or the pace is going a bit quickly today. Let me know in the chat there. Okay. Remember, be honest, because that's often I don't always have the visuals, and so the thumbs help me understand kind of where we're at. Okay. 3.1.5, it says, find the coordinates of the turning point of E. What do I need to do to get the coordinates of the turning point of E? Who can help me? Maybe if we think back to our previous lessons on parabolas, to find the turning point, there's actually two ways. I'm interested if any students have any suggestions about how we might find the turning point. Kat has said the turning point formula. And I agree, Kat, there is a formula. What is that formula? Aha, yes. So, Samsanti, what do you think it is? Maybe you've learned about it at school. Let's have a look.
You're going to use the formula that says y is equals to negative b all over 2a. Then
Okay,
after finding the answer, you're going to substitute it in the equation.
Perfect. So minus b over 2a. The other thing, Samsanti, is that it has to be in standard form. Hey, so you can only use minus b over 2a if it's in standard form. But luckily this is. So we are good. Awesome. And then the other thing that Samsanti said was you have to plug this x value back into the original equation. So what is my b value? It's minus 4. So it's minus 4 over 2 times a, but the a is 1. So it's 4 over 2. And so the x coordinate of e is just going to be 2. And now I need to know what that y value is. So what is the y value that's going to go with e? Well, I guess what I need to do is I need to put 2 into the function f. So I go 2 squared minus 4 times 2 plus 3. And that is going to give us minus 1. And so e is going to be the point 2 minus 1. And that kind of makes sense because you can see e is in line with b there. Okay. So to find the axis of symmetry, we just use the minus b over 2a thing. And then to find the y value of e, we subbed it back into the equation f. Cool. Now things get a little bit more interesting. So it says, for what values of x? So for what values of x is the following thing true? Now, this by itself looks a bit weird, but I want to ask, where have you seen x squared minus 4x plus 3 before? And where have you seen x minus 1 before in the question? I want to know, where have we seen those things before? So yeah, those numbers aren't random things. They're actually the equation of f and the equation of g, the function. So what this is really saying is for what values of x is f greater than g? And because f of x and g of x deal with the y values, it's really saying when is f above g? So when is f above g in terms of the y values? So I'm going to look at my graph, and if I start all the way to the left, do you think f is above g at that point? If we started all the way to the left where my green highlighter is f above g at that point? Have a look. What do you think? Well, if I'm here and I choose an x value, it looks to me like the f is up there and the g is down there. See, so look at this. If I choose like x is minus 1, this is telling me that f is high up here and g is all the way down here. And then if I even go to like, say somewhere, even if I keep going, if I go to like here, so let's say like at that point, if I go up, f is above and g is below. So we're looking for the x values where the function f is above g. And I think it is there all the way until I get to that point. So can you write down, can you describe that yellow streak over there for me? So the yellow bit there Now we worked C out earlier on. I think C was 1 and D was 3. So we know that X must be less than 1 for F to be above G. But there's another place. Okay, Kimane, hang in there. This question is saying, when is the graph F above the graph G? And what I'm saying is this first yellow bit, if I choose an X value here, the F function is up here. So its Y value will be like a big number. Maybe like it's like, I don't know, like 7 or 8 or something. Whereas at that same X value, the G function has a Y value that's going to be down here. Let's say it's like -2. So it's way below. F is above G. But we're not trying to do it for this one place. We're trying to do it for all the places. And what I'm going to suggest is that it's below the line, it's below the straight line, and then at that point they're equal. And then once we move to that side, F is above G again. And so I want to know, how do I describe that bit? Well, the way I would describe it is X is greater than 4. Now, in Paul, we could solve this equation, but yes, you could. You could solve it. That's the other option. I just think it's quicker. It's important to learn how to interpret graphs. The other thing you could have done, and Paul has raised this question, is you could have solved the inequality. So if you feel more comfortable, you could have done, what would I do? I'd say minus X plus 3 plus 1 equals 0. And you could have solved that. It's not even going to be, it's going to be greater than 0. Yeah, so you could have solved that and you'll get the same answer. But I think it's important that we learn how to interpret these graphs anyway. Okay, so X is less than 1 or X is greater than 4. It's the yellow bit here and the green bit here. Now, these types of questions, we're going to practice more. So let's try 3.1.7. And I would love someone to explain to me in like English, what is this question asking? So it's saying for what values of X again? So we know we're on the X axis, but what does it mean for F of X to be less than 0? Can anybody offer me an interpretation of what F of X is less than 0 means? Yeah, let's go to Fila. Fila, what do you think? How would you explain F of X is less than 0? What does that mean?
I think it means that where F at X is below the X axis.
Perfect. It's below the X axis, yes. So when it dips below, so it looks to me, would you agree that it seems to dip over here, like in this little patch in between? Isn't that where it goes below the X axis? Would you agree there, Fina? I'll unmute you if you can still hear
yes.
me. Would you agree?
Oh,
okay.
Yes.
Perfect. Okay, so we're on the same page. Awesome. Thank you, Fina. So now the question is, how are we going to describe that pink patch over here? So this is going to be 3.1.7. Well, we know earlier in the thing, we worked out that D is 3. And so the answer for this has to be X is greater than 1. Okay, so it's greater than 1. And it's going to be less than 3. So that will be my answer. And if we use the other notation, the interval notation, it would be circular brackets, 1 to 3, like that. Okay. Another quick vote, thumbs up. Where did I get the 3 from? Sinosipo, earlier in the question, we had worked out what D was. So we know that D was 3.0, and we used that from earlier in the question. Okay, quick vote, thumbs up if you're feeling okay, thumbs down if you're feeling a bit. So we're in between, some of us. We're at exam level now already. So it's, it's going to get a bit tougher, but we're building a firm foundation, which is awesome. Okay, we've got a little bit of time before our halftime break. So let's go and look at this question from 2017 from the Department of Basic Education exam. So what I want you to do for me first is I want you to identify what type of function is f and what type of function is g. So tell me in the chat, what type of functions are we dealing with in this exam question? Okay, so f is a hyperbola. Chrissy has said that. And then, yep, lots of people have got f is hyperbola. And the pink one is an exponential. It's a little bit of a, there's a minus x and a minus 4, but basically we're dealing with hyperbola and exponential. Now this is, in the last question, we were dealing with straight lines and parabolas. So we're kind of giving each function its time in the sun. Okay, now, find me the f of minus 3. Find me the f of minus 3. What is the f of minus 3 going to be? What does it mean to ask about the f of minus 3? So it's saying, what is the value of the function f when x is minus 3? So I feel like I just have to take the function f, and wherever there is an x value, I will put a minus 3. So that's already there. I have to put something in there, plus 2 plus 1. And this is saying, look, I want to put a minus 3 in there. So we get minus 3 over minus 1 plus 1. 3 plus 1, and that's going to be 4. Yeah, get that. Okay, then the next question says, determine x if the g of x is 4. So this is a little bit of a different question. I'm going to give you some time to try, but if you're unsure, ask a question. Find the value of x if the g of x is 4. See if you can figure that out. What would I need to do in order to... So g of x is kind of like the y value. So if y was equal to 4, what x value would you find? And it feels to me like I'll make the y 4, and now I have to solve this equation, because it was to do with g. And that was the equation of g. And when is it equal to 4? And now find the x. And this is an exponential equation. And to solve an exponential equation, you have to move, well, like any equation, you move everything to one side. So you get 8 is 2 to the minus x. And then we want to make the bases the same. And then we can say 3 is minus x, or x is minus 3. Yep. So the answer to 1.2 is x is minus 3. Okay. Find me the asymptotes of f. So find me the asymptotes of f. We're doing nicely. Remember, asymptotes are lines that you get closer and closer to, but you never touch. And it's referring to the hyperbola. So if I look at this hyperbola, the one that I remember from previous lessons when we were drawing hyperbolas is one of the asymptotes comes from sort of division by 0. So the one asymptote is going to be x is minus 2. That's going to be the vertical asymptote. Nice import, yep. Now what's the other one going to be? I know there's 2 asymptotes for f. What's the other one going to be? Yes, So the other one is going to be this number over here, the plus q, and so it's going to be y is equal to 1. Yeah. Okay, last one before the break. Write down the range of G. What is the range of G? Now, when we talk about range, we're talking about the Y values that are valid. What do you think the range of the function G is going to be? Might be helpful to have a little squiggle graph just to give you some guidance. What do you think the range of the exponential function G is going to be? So when you think of G, G is an exponential function, but it also has an asymptote. And the asymptote should be at y equals -4. But now you have to ask yourself, what side of this graph is the exponential function going to be on? Now, if you think it's going to be on this side, you'd say y is less than -4. If you think it's going to be on this side, you'd say y is greater than -4. Now, what does a exponential graph normally look like? Well, a simple exponential graph would look maybe like that. And then if it got shifted down, it would look like that, I guess. This has a -x. And what that does is it reflects it over the y-axis. But that's not going to really make too much of a difference, because instead of going like that, it's just going to go like that. But I'm pretty confident that the exponential function should be on this side. Now, what does that mean about the range of the graph? It means that it only exists in this region over here. So you can see, like, if I had a point on the graph and it was here, it would have a y value that went there. If I had a point over here, it would have a y value that was there. So what is my answer going to be for the range? All those tips there. Okay, because I don't think it's going to be less than -4. I think it's going to be above the -4. And so the range should be that the y is greater than -4. It's basically all these y values here. The exponential function can never get below those dotted lines there. Okay. Look at us. We've almost done 2 whole exam questions. I think we need a bit of a break. And so what I'm going to ask you to do is to turn on your cameras and stand up with me, and we're going to get our second bit of exercise because we've worked hard. And yeah, I think we need a break.
Please turn on your cameras, guys. Let's see your lovely faces.
Start by shaking up your arms, pretend they're made of jelly or rubber or licorice, whatever you want to do, and just wave them around like you're just very loose and flexible. And then I want you to look off into the distance. So find somewhere else in your room, far away, and look at the furthest corner you can, so that your eyes have a chance to go from focusing somewhere close to focusing somewhere far away. So we're going to try and take care of some of our eye health as well as we do these breaks. So I'm looking somewhere, I'm giving my eye a break. And then I'm going to start by loosening up, and I'm going to roll my shoulders. So roll my shoulders, I'm rolling them back. And then I'm rolling them forward. Then I'm going to stretch my neck to the one side. And then I'm going to move my neck to the other side. Okay. Then I'm going to start rotating from my hips a little bit. So one side. And I'm just going to start slowly. And then as I do each rotation, I should feel myself loosening up and going a bit further each time. Oh, clicking. Okay. And then, tell you what, let us do a tricep stretch. So stand like this. And then let's do the other tricep. Let's do a shoulder. Another one. And then just shake it all out. Shake everything out. Okay, let's get some heart rate up. Let's do the skipping today. We're just going to do 20. Make sure you've got space on the ground, that you don't whack anyone. And let's go in 3, 2, 1, 2, 3, 4, 7, 8, 10, 11, 12, 13, 18, 19, 20. And have a seat. Screen. And we're going to do a little Math 24 run. So again, as per normal, you can just put the one that you think you've got in the chat. You try to make 24 using the numbers on the cards. Yellow is traditionally the hardest. Red is the simplest, but sometimes that doesn't even always work out like that. See if you can get 24 using the numbers. So in 4 plus 4 times 2 plus 1. That looks to me like 8 times 3, which is 24. Yep. And you can also do 4 plus 2. So one day I said 4 plus 2 times 4 times 1, which is 6 times 4, which is 24. Or Kapotso has said you can go 4 minus 1 times, which 4 minus 1 times, but then you've used times 8. 4 times 2 is 8. Yes. Yeah. You can do that as well. So plus 1 is 3. Okay. Then the blue one, or Nompilo, the red one. Yep, I agree, Nompilo. That's good. Okay. Caitlin has said for the yellow, 3 times 5 plus 3 times 3, which would be 15 plus 9, which is 24. Yeah, I agree with you. I think you've got that one. Are there any other ways to do the yellow or the blue? Sonic has said, yep, Sonic agrees. 3 times 3 plus 3 times 5. And then Paul has said for the blue one, 4 plus 3, which is 7. What, how does that work? No, I don't think the blue one has been solved yet. So, because oh no, it is right. It's no 4 plus 7 times 7 is 49. But maybe, how would we do the blue one? So 7 times, yeah, the blue one is the one that's still remaining, unless I've missed something. Who can get the blue? I'm feeling pretty Math 24 today, so I'll give you a hint. 4 divided by 4 is 1. So if you know 4 over 4 is 1, how can you use the other two numbers to get 24? So it seems that what you do is you go 1 plus 7, and then you times by 3. Yeah. And because that would be 8 times 3, which is 24. Okay, fantastic. I hope you enjoyed that break, everyone. And I hope that you feel ready to rock and roll back to what we were doing.
Nicely done, everyone.
Nicely done, indeed. So we have done the first 4 questions of this past exam paper. The next one is to find the x and y intercepts of f. So you need to find me the x and y intercepts of f, which is the hyperbola. Go ahead and find me those. Typically, when we find the x and y intercepts, we use a set method. So think back to when you drew graphs. What did you use to find the x and y intercepts? So let's have a look at what people are saying in the chat. So for the y-intercept, students are indeed getting 0 and then minus a half or minus 0.5 for the y-intercept. And then for the x-intercept, what are you getting? What have we got for that one? So to find the x-intercept, we make y 0. I can move that across. I can move that across. And I seem to get x is 1, which would make my x-intercept 1, 0. According to that. And I see Kapotso also agrees with me. Does anybody else agree with me on that, on the 1, 0? Okay, fantastic. Okay, good. So it's nice to know there's easy marks in the bag there. Now, 1.5 is that one. Now we're not going to do 1.7 because that's drawing the graphs, and we've done quite a few lessons on drawing graphs. So if you're unsure about how to draw the graphs, then I would suggest going back to the earlier Watobe lessons where we did like a whole lesson on just drawing graphs. But we are going to do 1.6. So 1.6 says, determine the equation of the axis of symmetry of F, which has a negative gradient. So this is rather interesting. F is a hyperbola, and hyperbolas have axes of symmetry. If you want to find the axis of symmetry, a really important idea is to know which point it has to go through. So if I'm talking about this hyperbola, I want to know what is the special point that you know that this axis of symmetry has to go through, because that's the key for 1.6. What is the special point that it has to go through? So you can imagine that, I don't know, well, I do know, but you have these asymptotes, and then these asymptotes are going to play a role. What's the special point that my axis of symmetry has to go through? Okay, so if you think of the asymptotes, the one asymptote was x equals -2. The other asymptote was y equals 1. Give me a thumbs up if you follow. So like I'm trying to visualize this hyperbola. I've worked out where its asymptotes were earlier in the question. So are you okay with me saying I'm using x is -2 and y equals 1 on this little scale drawing over here? Okay, now these two lines, these two asymptotes meet at that point. And what I want to suggest is that the axis of symmetry has to go through, there's two of them. The one goes like that. The other one is going to go like that. But before we even worry about which one we're after, what is the blue point going to be? What does the blue point's coordinates have to be? Raise your hand if you've got, you can say it audibly, or you can pop it in the chat. What is that blue point going to be? Well, it's in line with x is -2. You're quite right. And it's in line with 1. So the coordinate for that is going to be -2, 1. Now, there are two axes of symmetry. There is, I'll call it the green one, and there's also going to be a blue one. Which one is the one do you think that I want for this question? It says the one that has a negative gradient. So do you think I want to find the blue one's equation, or do you want to find the green one? Okay, because the blue one is the one that has a negative gradient. Now, here's a wonderful thing. The axis of symmetry of a hyperbola will always be 1 or -1. So m for this one is going to be -1. For the green one, it would be 1. And all we need to figure out the equation of a straight line is we need the gradient. So I know that the blue one is -x plus c, where the minus comes from the -1 here. And now what I do is I use the point -2, 1, which I know is on this line. Find me the equation of the straight line now. What is the equation of the straight line going to be? Yes, you can import. You can use that as well. You'll get the same answer. Let's just check we get the same answer. Well, we should get the same answer. You can use that way as well. I'm just going with the way that I think most students will understand though the first time they see this. That one is it's a little bit hard to understand why it works, but it does work. So I'm going to take this minus 2, 1, and I'm going to use it somehow to figure out C. What am I going to get? Okay, so I take minus 2 is x, y is 1. So I go 1 equals minus 2 plus c. And then 1 equals 2 plus c. I take away 2 from both sides. C should be minus 1. And the equation of my axis of symmetry is going to be minus x minus 1. Okay, that was a tough question. All right. I like what I'm seeing. Akonela and Tembe. Cool. Give me a thumbs up if you're with me. Give me a thumbs down if you are feeling a bit lost. That was a tough one. Okay. Now remember, for those who are feeling a bit confused, you can always go back and watch the recording of this video. And if you watch it a second time, you'll find that things start to make, you don't even have to watch the full thing a second time. You can just watch the bits that you are unsure of a second time. And that will be helpful. Okay, let's see if we can squeeze in one more question. Let's see if maybe that's not the right one. Let's just have a look at this one. I quite like this little short one, just to finish off, to make sure you're getting your full mathematical experience for today. So we are given, the sketch below shows the graph of f, and I'm going to suggest that f is the hyperbola. And you're given the graph of G, which I'm going to suggest is the blue one. First question, write down the value of W. What do we think the value of W is going to be? Who feels like they know this? Or how can we work out what the value of W is? W is this thing over here. A little bit sneaky. I'll give you a tip. Think about the asymptotes of f. Where are the asymptotes? They might tell you. It's not going to be 7. I'll give you another hint. There's a sneaky asymptote sitting over here, and there's a sneaky asymptote sitting over here. Normally with hyperbolas, you can see the asymptotes when they're off the axes, but these asymptotes are on the axes. And what that means is that W is actually, Kevin has got it, so it is, W is actually 0 because it hasn't shifted up or down. It's just stayed exactly where it's like a boring hyperbola. Well, not boring, but it's just, yeah, you can't, the asymptotes are on the axes. Okay, nicely done. Now, 1.2, the point minus 27, so here's the point minus 27, it lies on F. Calculate the value of K. So the value of K is up here. Find me the value of K. What's that going to be? So I think all I need to do is sub this value in. So minus 27, I'm going to replace the y with the 7. The k I don't know. The x has to be minus 2, and the w was 0. So this minus 2 times 7 should give me a k value of minus 14. Yeah, so k will be minus 14. Now, there's not going to be enough time to fully complete 1.3, but I just want to know what you do. So it says calculate the x coordinates of P and Q, which would be these values here. We're not going to do it, but I just want to know, how would you find the x coordinates of P and Q in this question? I just want to know from in the chat or from someone, what would you need to do? What's special about those points? Well, they are what? What type of points are P and Q? They are intersection points, yes. And what do you do with intersection points? You just equate the functions or you substitute them into each other. In this scenario, what you would do is you would say, look, the first function was 14 over x, which is the function f, and it must be equal to minus x minus 1. And so if you solve this equation, you will get the x value that is here and the x value that is here. And then if you want the y value, you take those two x values and you would sub them back into either of the originals. Okay, everyone, that was a good, solid session today. We did 3 old exam questions, and you can see that your level is improving each time we did this. Lebo, if you could just put the link to the quiz for the week on, that was I was really impressed by the classes kind of focus there. If there are any final questions, now is the time to raise them. Otherwise, yeah, I think next week what we're going to do is we're moving on to trig graph interpretation. And it'll be similar to this, where we take trig graphs, we look at some basic questions around them, and then we look at some old exam questions to give you a sense of what level we need to get to. But yeah, well done for what's the curriculum for term 3? Sinosipo, it's going to be data handling, it's going to be, well, statistics, basically, probability, and then what we call the trig area or the trig triangle rules. In some schools, they might do some measurement, but yeah, that will be the focus in term 3.